Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing advantages of feedback. In our previous class we have seen in detail about advantage of negative feedback of each topic in detail in our previous classes. In this class we will just summarize for easy remembrance for the preparation of examination, and to understand it in a better way, what are the advantages of negative feedback. So, the advantages of negative feedback are stability of gain, reduction in distortion, reduction in noise. So, stability of gain, gain with feedback is resembled by AF, F indicates feedback. Stability of gain, AF is stabilize, reduction in distortion, DF, DF is reduced, reduction in noise, NF, NF is reduced, increased bandwidth, BWF, bandwidth with feedback is increased, change in input resistance, RIF, depending on the type of feedback amplifier, the input resistance may increase or decrease, change in output resistance, ROF. So, the notations are clear now. Gain AF, distortion DF, noise NF, bandwidth BWF, input resistance RIF and output resistance ROF. So, here we have to know with feedback and without feedback. So, without feedback what will be the symbol of input resistance? Ri. With feedback it is RIF. Without our feedback output resistance R0, and with feedback it is ROF. BW without feedback and with feedback BWF. A without feedback, AF with feedback. So, these are the notations, you no need to confuse. F indicates with feedback, and this is the block diagram of negative feedback. An amplifier of gain A and a feedback network of ratio beta are connected in this manner, in which the feedback network will take a part of output and will give it to the input to the mixer in opposite phase. If the input signal is resembled by plus, XF will be minus. So, when the feedback signal is in opposite phase with the incoming input signal, it is known as negative feedback. Negative feedback is used in amplifiers. So, what is the XF value? It is beta times of output. A part of output is fed back to the input. It is mixed in the mixer. So, here Xi. So, what is Xi? Going input to the amplifier, which will be the difference of these two signals, XS minus XF. So, Xi is equal to XS minus XF. This is the block diagram of negative feedback. Now, coming to gain, how gain is stabilized, important relations need to be remembered while doing stability of gain. This is a gain equation of negative feedback. AF is equal to A by 1 plus A beta. The gain can be stabilized by applying one condition. This A beta value is made very large compared to this 1. So, what happens? This 1 can be negated. So, we are left with A by A beta, where A get cancelled, and you are left with AF is equal to 1 by beta. So, the gain with feedback is depending only on beta. What is beta? It is the feedback ratio. It is in the feedback network, and the feedback network is generally a passive network, generally made of resistors. So, we are now able to make gain more stable because it is not depending on any active elements, it is depending only on beta. So, by applying the condition A beta very large compared to the 1, AF can be made independent of A. What is A? Gain of the amplifier. This gain of the amplifier means it is decided by the BJT or the FET or the active element used. Now, when the AF is made independent of A, it means it is now depending only on beta, and hence it is more stable. Or the other condition may be sometimes due to fractional change in gain with feedback. So, fractional change in gain with feedback is represented by DAF by AF. If there is a fractional change Then we have seen the derivation for this in the previous class. It comes as dAf by f is equal to dA by A, the fractional change in gain without feedback divided by 1 plus A beta. So this dA by A is divided by a factor. So what happens? dAf by AF is reduced. So even if there is a fractional change in gain with feedback, it will be less compared to the fractional change in gain without feedback. And then we got two important equation. One is a D sensitivity, which is equal to 1 plus A beta. So what is 1 plus A beta? If it goes there this side, so it will be dA by A by dAf by AF, that is fractional change in gain without feedback by fractional change in gain with feedback. Another term is sensitivity. Sensitivity is equal to 1 by D, which is equal to 1 by 1 plus A beta. So the reciprocal of this, that is dAf by AF by dA by A. So these are the very important equations we have derived under stability of gain. So stability of gain can be achieved by A beta greater than 1, and the fractional change in gain with feedback will be very less compared to fractional change in gain without feedback. The next topic is reduction in distortion. So the distortion is reduced. We have seen the equation dF, that is distortion with feedback, is equal to distortion without feedback divided by 1 plus A beta. Reduce means divided by D by 1 plus A beta. Reduction in noise. So NF will be equal to, NF is equal to N by 1 plus A beta. So whenever it is reduced, when the equation is saying reduce, so divide that by 1 plus A beta, reduce. Okay. Now coming to increased bandwidth, it can be easily proved by the equation BWF is equal to BW dot 1 plus A beta. If it is increased, multiply the term BW with A 1 plus A beta. If it is reduced, divide 1 plus A beta. So the equations are easy to remember also. This is a frequency response graph. This one is without feedback. And this is with feedback. So the difference between FH and FL is known as bandwidth. So we observe that bandwidth with feedback is larger compared to bandwidth without feedback, because here the lower cut FL is lower cutoff frequency, which is reduced. It's reduced means the equation will be FLF is equal to FL by 1 plus A mid beta, and here FHF is increased. Increase means multiply, FH dot 1 plus A mid beta. So in this way you can see that how FLF is reduced and FHF is increased, and so how the bandwidth with feedback is increased. So these are the few important equations to remember under the topic increased bandwidth. The next topic is change in input resistance, that is RIF. We are having 4 feedback amplifiers: voltage series, current series, current shunt and voltage shunt. For current series, input resistance means at the input side how the resistance is changed. So here, as you know, the first word tells about the output and the second word tells about the input. For series connection, the resistance will be increased, and for shunt connection resistance will reduce. It's an easy way to remember. So for voltage series, what will be the resistance? It will be increased. What will be the equation of input resistance? RIF is equal to RI times 1 plus beta AV. For current series, RIF series means increase, so multiply RI dot 1 plus beta GM. This is a gain of current series. For current shunt, the second word here is shunt. Shunt means parallel connection, so it will be reduced. So divided by RI by 1 plus beta AI. Now coming to voltage shunt, it is shunt connections. Shunt connections means resistance will reduce. So it will be RI by 1 plus beta RM. Okay. So for voltage series the gain is AV. For current series the gain is GM. current shunt AI and RM. Okay, so the gains are AV, GM, AI and RM. So it is easy to remember, na? The second word tells about the input. Series connection increased. Increase means multiply. Ri dot 1 plus beta AV. Series 1 plus beta GM. Shunt divided by Ri by 1 plus beta AI. Voltage shunt. Shunt means divided. Ri by 1 plus beta RM. Next topic is sixth one, change in output resistance ROF for voltage series. The first word tells about sampling output. For voltage sampling, the connections are shunt. Okay, shunt means reduced. Reduced means divided. R0 by 1 plus beta AV. For current series, current sampling means series connection. Series means increased. So ROF is equal to R0 times of 1 plus beta GM. Current shunt, current sampling. The first word tells about output. We are talking about output resistance. So need to see the first word, output. Current. Current sampling means series connection. Series means increased. Output resistance will be increased. So ROF is equal to R0 times of 1 plus beta AI. For voltage shunt, voltage sampling, voltage means shunt connections or parallel connections, so it will be reduced. So ROF is equal to R0 by 1 plus beta AI. This will be RM. For voltage shunt, the gain is RM. So it will be, equation will be R0 by 1 plus beta RM. Okay, so here is ROF increased or decreased? It is reduced. So ROF is reduced. Here ROF is increased, series increased. Here ROF is increased. Here ROF is reduced because it is divided by. So voltage for voltage sampling, what are the connections at the output side? Shunt. Shunt means reduce, ROF will be reduced. For current sampling, current sampling means series connection at the output, so it will be increased. Okay, so in this way you can say that the output resistance is changing depending on the type of our feedback amplifier used. So for voltage series it is reduced, for voltage shunt it is reduced, for current series and current shunt it is increased. So there is change in output resistance depending on the type of feedback amplifier. These are the gain equations of different feedback amplifiers. For voltage series, the gain is AVF is equal to AV by 1 plus AV beta. For current series, it is GMF is equal to GM by 1 plus GM beta. For current shunt, it is AIF is equal to AI by 1 plus AI beta. For voltage shunt, it is RMF is equal to RM by 1 plus RM beta. So these are the different feedback amplifiers gains. I hope now it's very easy to remember this advantages of negative feedback, stability of gain AF, reduction in distortion DF is equal to D by 1 plus A beta, reduction in noise NF is equal to N by 1 plus A beta, increased bandwidth BWF is equal to BW dot 1 plus A beta, change in input resistance, so RIF is changing, change in output resistance ROF is changing. For voltage series and voltage shunt it is reducing, for current series and current shunt output resistance is increasing. So we say that there is change in output resistance. So these are the very important equations related to advantages of negative feedback, and the explanation in detail are given in the previous video. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.